In the previous lecture, we introduced 3 ways of getting more labeled data and reviewed the first way, which was to use a proxy label. Another strategy for dealing with a lack of labeled data is to build a labeling system. Let's say we're building a system to identifying an incoming email as urgent or not urgent. But we don't have labels because in the past, our agents simply handled all the emails as they came in. What can we do? Well, we could first build a system that allows our triaging agents to mark emails as urgent or not urgent before they handle them or put them in the queue. And then when we have enough data with labels, we can go off and train a machine learning model. Labeling systems can come in many forms. The key approach is to be creative in figuring out how to build a labeling system. I came across one example of a creative labeling system because I'm on the board of an institute that develops technology solutions relevant to surveying. A researcher there, Anthony Reisinger, had thousands of drone images and wanted to train a machine learning model to classify the images based on their susceptibility to oil spills. For example, this is a picture taken from a drone of a coastal area. And Anthony wanted to be able to classify this image as showing a salt marsh and exposed tidal flats. Knowing this, it's possible to identify what would happen if an oil spill occurred here. The coastal environment is very dynamic. Rains, flood, wind, construction, many things can change the coastline, so the Conrad Blucher Institute does periodic surveys of the coastline. Being able to classify images means that they could use these surveys more often or in rapid response to events like oil spills. So Anthony wanted a machine learning model to classify images. And that was around the time that we in Google Cloud were getting ready to release AutoML. This is the technology that you used earlier in this course to classify images of leaves. My colleague Amy Unruh offered to help Anthony out to try AutoML on his problem. But remember that a machine learning model needs labeled examples. Did they have to go through thousands of images and hand label them? Anthony came up with a very smart labeling system. It turned out that around the time that the drone images had been taken, a survey had also been done, and each part of the shoreline had been digitized and classified into the type of coast. This is why in machine learning, it helps to know the domain you're working with. Neither Amy nor I could have known about this digital shoreline information that already existed. You see the digitized shoreline in oranges and reds. Those are 2 different types of coastal features. So Anthony took the metadata of the drone images and extracted out the GPS location of the aircraft and which way the airplane was headed. And based on this, he could calculate the field of view of the drone camera, and that's a wedge shape that you see. Then he could calculate what part of the coastline the camera was seeing, and based on that, he could look at the digital shoreline map and label each of the images. In this particular image, there are 3 unique labels: sandy beach, salt marsh, and exposed tidal flats. And they could write a program to do this automatically. And they could take this program and unleash it on thousands of images, thereby labeling all of those images at scale. No need to hand label each of the images. Pretty cool, eh? And once they had the images and the labels, they could apply AutoML to it. And that part was as easy as the leaf classification you did in the previous module. We'll come back to this point later of how collecting, organizing, and labeling data can be the most time-consuming and creative part of a machine learning project. The training part is very easy. What if your historical data is not labeled, and there is no way to build a labeling system for it? Then third option, you could send your historical data to a labeling service. These are companies that specialize in manually labeling documents or images based on criteria that you specify. One big drawback with a labeling service is that it's not part of your normal workflow. You have to send the data out to be labeled. It's much better, if possible, to incorporate labeling into the workflow of the humans who will make decisions based on the model. After all, in the future, the machine learning model is going to make errors, and these users will need to be able to correct these errors by supplying the correct label and automatically adding to the set of training examples.